A particle has v of t equals 3t squared minus 12t plus 9, and p of 0 equals 0. What are the zeros of position, velocity, and acceleration? PVA. Here are the integral derivative relationships, and be careful about plus c. We have the following. To find the zeros of position, p of t, note that integral v of t dt equals p of t plus c. Since p of 0 equals 0, then c equals 0. So p of t equals 0 when t equals 0 or 3. To find the zeros of velocity, v of t, we factor our given expression. So v of t equals 0 when t equals 1 or 3. To find the zeros of acceleration, a of t, note that v of t prime equals a of t. So a of t equals 0 when t equals 2. Initial means t equals 0, so initial velocity is 9, and at rest means v of t equals 0. Velocity greater than 0, velocity less than 0. Acceleration greater than 0, time 1, time 2. Speed. Acceleration less than 0, time 1, time 2. Speed. Consider positive and negative pairings of velocity and acceleration for time 1 to time 2. Speed is the length of velocity, that is, s equals absolute value v. If the length of the velocity vector increases, then the speed increases. Speed increases when both velocity and acceleration have the same sign. We're moving right, then faster right, or moving left, then faster left. P of t, v of t, a of t. On 0 to 1 and 3 to 4, the change of position, which is velocity, is positive. On 0 to 2, the change of velocity, which is acceleration, is negative. When t equals 1, the change of position goes from getting more positive to getting more negative. So velocity goes from positive to negative. When t equals 2, the change of velocity goes from getting more negative to getting more positive, so acceleration goes from negative to positive. Speed is increasing for 1 to 2 and 3 to 4 due to same sign of velocity and acceleration. If we integrate velocity, we would get displacement, change of position. We have the following. If we integrate acceleration, we would get the change of velocity. Here's the following. We can rearrange these above integrals to solve for p or v at a certain time. If we integrate speed, we would get total distance traveled. What is the total distance traveled between time 1 equals 0 and time 2 equals 4? If we split the integral into sections where the integrand is strictly non-positive or non-negative, then we can move out the absolute value sign. In general, however, this does not equal that. And we have the following. To transform each of these three integrals to the positions, consider this. v, p. And we have the following. In splitting the integral into sections, we found the change of the positions while moving in one direction. This way, there is no overlap. Generally, velocity is positive when moving right, forward, or up. What is the average position, P_f of t, between t1 equals 0 and t2 equals 4? We have this, which equals 2. What is the average velocity, Vf, of t between t1 equals 0 and t2 equals 4? Average velocity, which is average rate of change of position, which is slope of secant line of position, and we get 1. What is the average acceleration, AAV, of t between t1 equals 0 and t2 equals 4? Average acceleration, average rate of change of velocity, slope of secant line of velocity, and we get 0. What is the average speed, SAV, of t between t1 equals 0 and t2 equals 4? If we split the integral into sections where the integrand is strictly non-positive or non-negative, then we can move out the absolute value sign. In general, however, this does not equal that. And we get 3.